Okay, ready? Great. On. Great. So right now I'm going to explain the water displacement method to find volume of an irregular object. So that for volume, matter is divided into either regular or irregular objects. The regular object is an object that is easily measured by length times width times height with a ruler. And that's mostly what you're used to from math classes for the last several years. You've been asked to find the volume of a regular object using length times width times height, the 3 dimensions. But when you are presented with an irregular object such as this stone that has lots of little crags and it doesn't really go in an easy length times width times height measurement, this is called an irregular object. And this is how the water displacement method works. So you all have colored water in front of you, and the first step is to pour the water, and this is green food coloring so that we can see it better through the glass, and find the beginning value of the water level. Notice I bring my eyes down exactly to eye level with the lines. That's important, so that the graduated cylinder stays level on the table, and you bring your eyes down, and I can see that the water level is at 59 milliliters. Notice how this is set up so that here's the beginning water level. Then what you do is carefully place the irregular object into the graduated cylinder, and then again going down to eye level with the reading. This came up to 61 milliliters. Notice how now the subtraction is set up so that the volume of the stone is, in this case, 2 milliliters. That's basically how the water displacement method works. So what you do is you find the volume of the water, and then the volume of the water and the object, subtract the volume of the water to find the volume of the object. Why does this method work? What do we know about matter? Why does this method work, the water displacement method? Works really nicely for irregular objects. Why? Got it?
Because it pushes up.
Perfect, it does. The object pushes up the water level. That's all it is, you're right. The water level pushes up the object pushes up the water level.
Wow.
Good, that's relevant. I need a specific, Henry. Why? What is Bennett saying? He's saying the object, the stone, pushed the water level up. Why does this work?
Because it's like contained in the tube. So when you fill up more, it'll push up.
And I like how Henry mentions this. It is contained into the cylinder, so we're not losing any of the water. No two objects can take up the same space, so that the water and the rock cannot occupy the same space. So this method works because the water and the stone will not occupy the same space. The stone will, as Bennett nicely said, push up the water. So that's why the displacement, the stone displaced the water. The stone displaced the water, and our subtraction method for the water displacement method works because the stone displaced the water by the same volume of the stone. Did everybody get that? That's why this works. It's pretty neat because no two objects can occupy the same space, so it pushes it up. Good. In this activity, our goal for today, as I said, is just to practice the graduated cylinder. Tomorrow, there will be a much stronger focus on precision and significant figures. But today it is to practice the water displacement method and just a refresher on measuring the volume for regular objects. So everybody has rulers in the setup. Okay, camera off. Thanks, Joe.